Paraline drawings include both axonometric projections and oblique projections. They combine in a single view the scalability of multi-view drawings and the pictorial nature of perspective drawing. Parallel lines, regardless of their orientation in the subject, remain parallel in the drawing. This is the principal pictorial characteristic of paraline drawings. This oblique view shows the vertical axis remaining vertical in the drawing. The two horizontal axes appear to recede at some angle to a horizontal line on the drawing surface. This split screen shows that parallel lines in the subject remain parallel in both oblique and isometric drawings. However, horizontal planes in the oblique retain their true shape, while vertical planes are foreshortened. In the isometric, both horizontal and vertical planes are equally foreshortened. In both oblique and isometric drawings, lines parallel to the vertical axis remain vertical, while lines parallel to both horizontal axes recede at some angle to a horizontal line on the drawing surface. We call these lines axial lines since they are parallel to the three principal axes. Only axial lines can be measured and drawn to scale. Axial lines naturally form a rectangular grid of coordinates for finding any point in three-dimensional space. Non-axial lines cannot be drawn to scale. Establishing a three-dimensional grid helps us locate the endpoints of non-axial lines. After one non-axial line is established, lines parallel to it remain parallel in the drawing. A pair of non-axial lines establishes a sloping plane. There are three approaches to constructing paraline drawings. The first is a subtractive approach. This involves constructing a rectangular box that encompasses the entire subject and then removing material to reveal the form. The second is an additive approach. This requires drawing a paraline view of the parent form first and then adding the subordinate forms. The third approach begins with the principal plane of the subject, from which its form is extruded or extended into the depth of the drawing. A paraline drawing induces a powerful sensation of three-dimensional mass and space. However, the composition of lines can also be read as a flat pattern. This can lead to optical illusions and ambiguity in the reading of a paraline drawing. The depth of a paraline drawing can be enhanced with contrasting line weights or tonal values. A hierarchy of line weights can distinguish between spatial edges, planar corners, and surface lines. Spatial edges are boundaries of a form separated from a background by intervening space. Planar corners are intersections of two or more planes visible to the eye. Surface lines simply represent a contrast in color or value. Contrasting tonal values separate planes in space and describe the orthogonal relationship between horizontal and vertical planes.